So hello class. Hello class. Um, it's continuation of our discussion, series convergence test. So we have comparison test, and in this test, it involves comparison of a series to a simpler one whose convergence behavior is already known. So we have this original series. Okay, let's say we have a sub n, and then we compare that. Okay, we compare that with our simpler series, which is the summation of b sub n. Okay, and by focusing here in the summation of b sub n, we determine if this is convergent or divergent. Convergent or divergent. Okay, so if okay, so if b sub n, or this summation of b sub n is convergent, so does the summation of a sub n. If the summation of b sub n is divergent, so does the summation of a sub n. So that is the condition here. Okay, so I just make it simpler. Okay, simple for you to understand. Okay, so this comparison test is best used when the target series resembles a known geometric or p series. Okay, so it is easy to use when our, let's say, when our summation of b sub n is in geometric or p series. Okay, so let's have an example here. Okay, so given that we have this following series, okay, and we need to determine if this series is convergent or divergent using any test. Okay, in this comparison test, we are using any type of test. Okay, so we're just, the idea here is that we're deriving, we have this let's say we have this the summation of a sub n, and we're deriving from here the summation of b sub n, and then from this b sub n we are using any type of test. Okay, and then from that, after using that test, or after using a specific test, we can determine if this if it is a convergent or divergent. Okay, okay, divergent. And based on our answer here, okay, so if the b sub n, the summation of b sub n is convergent, so does this a sub n. Okay, if the summation of b sub n is divergent, so does our a sub n. Okay, so going back in our example, so we have 1 over 2 plus 1 over 5 plus 1 over 10 plus 1 over 17 plus so on and so forth. Okay, so we must find first the general formula of this term. So the general formula of this term, so that will be 1, okay, over 2n plus 1. Okay, that is the general formula of this series. Let's say we have this s sub n, okay, the series. Okay, next, from this general formula, okay, let's derive let's derive the summation of b sub n. Okay, let me represent this as, okay, wait, so 2n. Okay, so I'll represent this as summation of a sub n. Okay, so we need to find the summation of b sub n. Okay, so how do we do that? So let's analyze our a sub n. Okay, the summation of a sub n. If we replace all n by infinity, or let's say if the n here, okay, if the n, or this 2n, rather increases or gets bigger. Okay, so if 2n gets bigger, this plus 1, okay, this plus 1 can be disregarded. Okay, so by analyzing the behavior as n gets bigger, okay, this plus 1 can be disregarded. And then from that idea, our we can say that our summation of b sub n is equal to 1 over 2n. Okay, so now we have this summation of b sub n. So let's try using tests, okay, to identify if this summation of b sub n is a convergent or divergent. So if we get or just using, let's say, let's use let's say we can use the limit here, okay, limit as n approaches infinity. Okay, just simple limit, we can identify if this summation of b sub n has if this limit diverges or if this series diverges or not. Okay, so we have 1 over 2n. Okay, so by analyzing the behavior, okay, if we replace the n by infinity, okay, it approaches 0, right? It approaches 0. So there's a limit here, and that is 0. And since there is a limit, okay, since there is a limit, okay, since there is a limit, therefore the the summation of b sub n is convergent. Okay, it is a convergent. And okay, and since you have the idea that b sub n is convergent, okay, another conclusion here, and since summation of b sub n is convergent, therefore the summation of a sub n is convergent. Okay, so that's how you perform the comparison test. Okay, again, given that you have this a sub n, going back here, given that you have this a sub n, you just simply derive the summation of b sub n, okay, the second series, and then using any test, okay, any type of test, or just getting the limit of this series, you can identify if this second series, okay, this b sub n is convergent and divergent. If it's convergent, therefore your a sub n or your original series is also convergent. Otherwise, okay, if it's divergent, if the summation of b sub n is divergent, okay, the summation of a sub n is also divergent.